Now we're going to begin our journey into nomenclature. We can break nomenclature down into four parts. Monatomic ions, which are things like sodium chloride. Variable charge cations, which include all the transition metals. As an example, iron 3 chloride. We can have polyatomic ions, mainly anions, and here we see an example of sodium sulfate. And then we can have binary molecules, which are going to be two nonmetals bound together. In this video, we're going to focus on monatomic ions. With monatomic ions, we're going to deal mainly with the metals of group 1, group 2, and group 13. These metals all have a fixed charge, and their group is going to determine their charge. If we look at group 1, they're going to have a 1 plus charge. Group 2 is going to have a 2 plus charge, and group 13 is going to have a 3 plus charge. So in order to use these metals in naming, we just pull the name off of the periodic table that corresponds to the symbol and use that. This table summarizes the names and their symbols as they correspond to the group 1, group 2, group 13, and some other fixed charged metals. You will need to familiarize yourself with this table so that you know that these metals are all going to be fixed charged and there's nothing special that we have to do to use them in our naming policies. Next, we can look at the anions. And our anions that are going to be monatomic are our nonmetals in group 14, 15, 16, and 17. These are all going to have a fixed charge, again, based on their group location. Group 14 will have a 4 minus charge. Group 15 will have a 3 minus charge. Group 16 will have a 2 minus charge. And group 17 elements, the halogens, will have a 1 minus charge. To signify that these nonmetals have a charge, we take their name from the periodic table and change the ending to IDE. The halogens follow this rule very easily because they take the INE ending and change it to IDE. The rest of them, though, carbon changes to carbide, silicon changes to silicide. They are not as straightforward as you might expect, so you'll have to familiarize yourself with these endings to know that nitride is N3 minus and phosphide is P3 minus. It is imperative that you learn these names because they will not be provided to you on a test or an exam. You will have to know these endings inside and out in order to correctly answer questions on an upcoming exam. Let's go ahead and put this together so that we can name an ionic compound based on monatomic ions. The first thing we want to do is determine the metal name from the cation that's present. Once we've determined the metal name, we can then determine the nonmetal anion name and place that second. For example, let's look at CaCl2. Ca is going to be calcium, and because calcium is in the group 2, it has a 2 plus charge. The Cl is for chloride, and that's going to be a halogen, so that has a 1 minus charge. So we're going to give it the name calcium chloride. Now you'll note that when we looked at the formula, there was a subscript 2 next to the chloride. We have to have 2 of the chlorides because they have a 1 minus charge to cancel out 2 plus charge from the calcium. So every time we see something like this where our charges are not the same, we're going to have to make sure that we balance our charge with our formulas. You'll note though that we don't have to do any balancing to the name. Calcium, because it has a fixed plus charge, we know is going to be 2 plus. And chloride, because it has a fixed charge of 1 minus, we know that we're going to have to take 2 chlorides per every calcium that we have present when we have calcium chloride. Now that we have practiced naming a compound from its formula, let's try to determine the formula from the name. the first thing we want to do is find the symbol and the charge of the metal cation. Then we're going to find the symbol and the charge of the anion. We're going to put the metal cation first and then place the anion second. And we're going to use the superscripts that are the charges to determine the subscripts by bringing them down and sort of cross multiplying. So let's take magnesium bromide as an example. The symbol for the cation is Mg. The charge is going to be 2 plus because it's a group 2 element. Bromide is going to have the symbol Br. And it's going to have a 1 minus charge. We typically don't indicate the 1 when we write the charge, but it's alright if you want to put the 1 just to signify that you have the 1 minus charge. Now, when we put these two together, we're going to put the metal first. So we're going to have Mg2 plus and then Br 1 minus. So our magnesium bromide is almost there. But you're going to note the magnesium has a 2 plus charge and the bromide has a 1 minus charge. So if we take the 2 plus charge from the magnesium and bring that down next to the bromide as a subscript, that's going to tell me that I have to have 2 bromides for every magnesium. When we write our complete formula, we don't want to include the charges. So we're going to erase our charges and write MgBr subscript 2 in order to correctly identify the formula from the name of the species. I hope this seems pretty straightforward to you, because it is. And the more time you spend practicing these, the more it will be apparent that these aren't that difficult to name. I want to give you some practice molecules here on this page, so you'll all make sure that you pause the video and write these down. I want you to practice these name conversions, mainly from the formula, before you come to class so that you're prepared to do some more practice in class and get a good handle on naming compounds from their formula.